Hello, and in this lesson we will begin to look at ways in which we can present single variable data. The first of which is on a frequency table. So we're going to do this by looking at the question above. A soccer team recorded the number of goals they scored in their first 10 games, and we're required to record the data on a frequency table. Frequency tables generally have 3 columns and may include the last one. The first column that we're looking at is the score, and that's got to do with the scores included in our set of data. The frequency looks at how often these scores occurred in the data set. The total, or the FX column, looks at multiplying the score and the frequency to show the contribution of that score to the overall total. And the cumulative frequency essentially counts up the total frequency as you go. Another way to express that is by saying that the frequency accumulates after each row, and that's done by adding on and totaling the frequency as we go down the column. Now, the score we can enter in as essentially 0 to 5. The frequency, again, is based on how often that occurs in the data set. So for score 0, that occurs once. Score 1 occurs 3 times. Score 2 occurs twice. Score 3 occurs once. Score 4 occurs twice. And score 5 occurs once. Now, the FX column, again, is done by multiplication. So score 0 contributes with 0 total goals. Score 1 contributes 3 goals to the total. Then we have 4, 3, 8, and 5. And now the cumulative frequency is based on adding the frequency as we go along. The frequency starts off as 1. Score 1 contributes 3 times, so the total frequency from this point onward is now 4. We add on 2, 1, 2, 2, and 1. Now the total frequency should be equal to 10, as they played 10 games and recorded their first 10 games. And the total FX, the sum of all of these entries here, should equal to 23, meaning that the team scored 23 goals that game. Our last question reads, classes 9G and 9M completed a mathematics test. The results of all students are below. This question requires us to first display 9G's results in a stem and leaf plot. And the stem and leaf plot pretty much looks like this, where when we record our data, we put all the units in our leaf section, and we organize our data with our stem, where we enter all of the place values that are above units in there. So that includes tens, hundreds, thousands, etc. So in this situation, we have entries that range from the 30s to the 90s. So our stem will start at 3 and end in 9, and we include all of the values in between. For our leaf, we have to account for every entry that is included above. So there's an entry of 39 for 9G's class. In the 40s, there's an entry of 41, and there is also 2 46s, so we include that twice. For the 50s, there are entries of 51, 52, 56, 57, and 58. So they're all included in our leaf section. For the 60s, there are entries of 63 and 69. For the 70s, there are entries 75 and 77. For the 80s, there's one entry of 81 and also an entry of 99. The second part of our question requires us to add 9M's results into the table as well. And what that will end up doing is forming a back-to-back stem and leaf plot. So pretty much what that is just having another leaf section on the left hand side of our stem. So we're going to enter those pieces of data again. They're going to be in chronological order as well, but we're going to do them from right to left. So there are no entries in the 30s for 9M's class, but there is an entry of 41. Again, there's no entries of 50 for that class either. So we're going to start in the 60s, where we have 63 and 68. We also have 72, 73, 75, and 79. 81, 84, and then 3 88s, which all get written in separately. 91, 92, and 95. What we can also do is label our leaf sections to ensure that we're knowing what class we are talking about. So in our leaf section, usually we would label what part of the data we're entering in that section. And there we have it, a back-to-back stem and leaf plot.